So this circle is getting a little wacky here. As we look at it, I just want us to get in the habit of knowing the difference between segments and lines. Again, this red line and blue line there are lines, not line segments, whereas these other ones, purple, orange, and blue, those are line segments. So let's get in the habit of seeing the difference there. When I see FC on the top, I've got a little hint there, and it has that little line on top. So it's probably going to be a line, not a line segment like DC. And again, F to C right there, cutting through that circle. And it's a line, so it's a secant line. That's what we're looking for. So since it's through, that's telling me it's a secant line. Okay. DC, again, right there, there's only a segment on top of it, not an actual line. So it is a line segment going through that circle. However, it's not a line, it's just a line segment. So we call that a chord. Okay, so when we say the word through like that, we're going to jump to either secant or chord, most likely. There's only a couple times where it would be diameter. DE, right there in the middle. Again, it's not a line, it's connecting the outside to the center, so that would be a radius. AB has a line on top, so it's probably going to be secant or tangent. And as you see, A and B, it only hits 1 point. So that would be a tangent line. Okay, tangent line, that's going to come up a ton in calculus. I'm excited for you guys to get there someday. BG, going through the center right that. It's a chord. It's 2 radii, but more specifically, it is a diameter. So chord you could technically get away with, but we want to be as specific as we can. It is the diameter. Before we move on, again, one more time, remember that these guys circled in purple are segments, and the guys with the lines on top would be lines. Big difference in this unit, knowing the difference between those two. Now, this is my favorite part. You guys have already done a Desmos activity over this, but those congruent circles, okay, that's where they just have that same radius, okay? So they have that same size, and their size is measured by their radius. So if you have something like this, a beautiful circle like that with a radius of 2, and then you have a random other circle somewhere else, but its radius is 2, you can say that those circles are congruent. So if we label them like E and R, you would say something like circle E is congruent to circle R. Something like that. All they need is that same radius, and we can call them congruent. Concentric circles, a lot of times people call this the bullseye situation, because if you've ever played darts, it kind of looks like a bullseye. So if I've got that circle, they've got that. Oh, that second one's going to be brutal on here. Maybe I can move it once that would not be concentric, because there we go. Okay, so something more like this, where they share that center point, making that little bullseye situation right there. So they've got that common center. Again, that is called concentric circles. Also comes up a lot, like if you're dropping water, putting a drop of water and stuff. You probably don't actually think that's cool, but I think it is. So that's not a perfect circle, but I'm just gonna leave it off. Hopefully that's making some sense. Concentric circles got that same center there. And just to add one more thing on the end here, if I did a circle like this, and a circle like that, those have names too. Let's see if you can figure out what they would be called. Pause the video, see if you can figure it out. So as you can see there, they are called externally tangent if they're touching on the outside of those two circles, and we would call those internally tangent if one circle is tucked inside the other. Hopefully you're having fun learning about circles.